Hello everyone, this is Syed Afri from the section C of AML. Today my selected topic is analyzing engagement on Instagram posts from the topic that is applied artificial intelligence and my roll number is 24951 So we will see the what is social media engagement in the brief introduction, that is engagement on Instagram includes likes, comments, shares, saves and the time spent viewing a post reflecting how users interact with content. High engagement signals content relevance and audience connection, making it as a key performance indicator for creators and brands. Engagement metrics helps refine content strategy by identifying what resonates with specific audiences over time. Unlike reach or inspirations, engagement measures active user participations rather than passive visibility. Unlike understanding engagement patterns enables better content personalization and targeted marketing in AI-driven platforms. Why analyze Instagram engagement? Engagement analysis helps optimize content timing, format, and messaging to maximize visibility and user interactions. Brands use engagement data to measure campaign effectiveness and return on investment in digital marketing. AI models can predict future engagement trends by learning from historical post performance and user behavior. Identifying high engagement content supports automated content recommendations and curation systems. Insights from engagement analysis improve user experience by promoting real and valuable content, relevant and the valuable content. And the next one is key engagement metrics on Instagram. Likes indicate initial user approval and are the most basic form of positive feedback on a post. Comments reflect deeper interactions and often signal strong emotion or intellectual engagement with content. Shares and saves suggest users find content valuable enough to redistribute or revisit later. Engagement rate is calculated as total interactions divided by the number of followers or inspirations, providing a normalized metrics. Video view duration and completion rate help assess how compelling video can not is over time. Data collection from Instagram. Instagram's Graph API allows developers to access public post data, including likes, comments, and timestamps with proper permissions. Web scraping techniques can gather public data but must comply with Instagram's terms of service and rate limits. Third-party tools like Hootsuite or Sprinkler provide aggregated analytics by integrating with Instagram's API. Data collected includes post type, captions, text, hashtags, image features, posting time, and user demographics when available. Ethical data collection requires user consent and anonymization, especially when analyzing private or sensitive interactions. So next one is future engineering for engagement prediction. Visual features such as color distribution, object detection, and image clarity are extracted using computer vision models. Texture features from captions and hashtags are processed using natural language processing to identify sentimental and topics. Temporal features like posting hours, day of week, and seasonality help capture user activity patterns. User-based features include follower count, past engagement history, and account verification status. Combined feature vectors serve as input to machine learning models that predict engagement levels for new posts. Machine learning models for engagement analysis. Regression models predict continuous engagement metrics like expected likes or comment per post. Classification models categorize posts into high, medium, or low engagement groups based on historical data. Tree-based models such as random forest handle mixed data types and capture nonlinear relationships effectively. Neural networks, especially deep learning models, can learn complex patterns from high-dimensional image and text inputs. Model performance is evaluated using metrics like RMSE for regression for F1 score for classification tasks. Deep learning in visual content analysis. Convolutional neural networks CNN extract spatial features from image to assess aesthetic quality and content relevance. Pre-trained models like ResNet or EfficientNet classify image content into categories such as food travel or fashion. Attention mechanisms help model focus on salient regions of an image that may drive higher engagement. Image embeddings generated by deep networks serve as compact representations for similarity and clustering tasks. Visual content analysis enables automated tagging and recommendations of visual engagement posts. Neural language processing for captions and hashtags. Sentimental analysis determines whether a caption conveys positive, negative, or neural networks to gauge user appeal. Topic modeling techniques like LDA identify recurring themes in successful posts, such as lifestyle or motivation. Hashtag analysis reveals trending topics and community interests that correlate with high engagement. Named entity recognition detects mentions of brands, locations, or public figures that may boost visibility. Language models like BERT generated contextual embeddings to improve understanding of nuanced caption meanings. Temporal and behavior patterns. Engagement often peaks during specific hours such as evenings or weekends, depending on the target audience. Day of week effects show higher interaction rates on Friday and Saturday for lifestyle and entertainment content. Seasonal trends like increased travel posts in the summer influence engagement, volume, and content preferences. User behavior models incorporate recency and frequency of interactions to personalize content delivery. Time series forecasting methods predict future engagements spikes based on historical posting schedules. Network effects and influencer impact. Posts from influencers with large followers bases tend to receive higher initial engagement due to audience size. Engagement spreads through follower networks where early interactions increase visibility via Instagram's algorithm. Collaborative posts between influencers amplify reach and engagement through cross-audience exposure. Community detection algorithms identify cluster of highly interacting users who drive sustained engagement. Network sensitivity measures helps identify key users whose content consistently triggered widespread interactions. Challenges in engagement prediction. Data sparsity occurs when new accounts or infrequent posters lack sufficient historical data for accurate modeling. Algorithm, algorithmic bias may arise if models favor certain content types or demographics present in training data. Instagram's dynamic feed algorithm constantly changes, making long-term engagement patterns difficult to predict. External events like viral trends or global news can cause sudden, unpredictable shifts in user behavior. Privacy restrictions limit access to detailed user data, reducing model granularity, and personalization potential. Case study predicting engagement for a travel brand. A travel company collected 10,000 Instagram posts with metadata including location, image quality, and the caption length. Features were engaged using CNN for image and TVF IDF for text combined with posting time and follower count. A random forest model achieved 87% of accuracy in classification posts as high or low engagement. Key predictors include image brightness, use of location tags, and presence of sunset or landscape visuals. The model recommended posting on Saturday evenings with nature-related hashtags to maximize engagement. Thank you for giving this opportunity to explain the Instagram engagement behavior in our lifestyle. Thank you.